That's one of the other things. Yeah, that's one of the other things I need to delve into. I've taken a class that Mina taught, but I haven't had a chance to put it into practice. So
Absolutely.
it's not really in my head yet.
All good. Perfect. All right. Looks like we're over my magic number of 160. And so we're about a minute past the top of the hour. So I'll go ahead and start sharing my screen and we can go from there.
Sounds great. Okay, thanks, Tom. And I'll just say first, welcome everybody to the R Govys seminar for January, the first one of 2024. And I just realized it is the first one for this year, and Tom is getting us off to a fantastic start. So I think this is going to indicate a great year ahead for us. And as for those of you who've been to an R Govys in the past, we usually let the speaker introduce themselves, so I'll let Tom do that. I just want to quickly mention that our Govys is sponsored by the R Consortium, the American Statistical Association, and who am I forgetting, Donna? Data Community DC. Anyway, if I forgot anybody, I'm sorry. But also this particular seminar is being sponsored not only by our Govys, but the American Statistical Association, Stat Computing Section, and the AI and Data Science Committee. So again, welcome, and I'm going to.
And Wendy, I'm just going to jump in because I see a couple of hands up.
Oh yeah,
I just want to remind people, because of the size of today's webinar, because of the size, we went to a webinar. So if we could ask the attendees to put their comments in the chat and questions in the Q&A. We're not going to go back and forth allowing people to talk, obviously, besides Tom.
Thank you, Donna. I already forgot that. You just told me 2 minutes ago. I forgot already. Yes, thank you. Yeah, we'll try to track things. Tom is pretty good, he said, at multitasking and checking on the Q&A. But yes, please put questions there so we could track them. And we will provide other kind of information in the chat as we go. All right, enough from me. Thanks, Tom. Go ahead.
Absolutely. Thanks again so much for having me. My name is Tom Mock. I'm a product manager at Posit and an eternally recovering academic from back when I did my PhD in neurobiology. So I'm here to talk about GitHub Copilot and more generally generative AI as it's available in RStudio. Obviously, the first slide here has its own kind of spoiler, which is intentional, which is that GitHub Copilot is now available in RStudio. It's finally here. It's been asked for a long time. And rather than taking one slide to talk about for 90 minutes, we'll actually go through some examples and kind of a little story of how this tool might be useful for you. I'm again going to post a link to the slides in the chat. These are Quarto slides, so what that means is that if you do open them today as I'm navigating, the slides will actually move along as I move along, but then in the future, when I actually turn off my set of slides, you can parse them at your own pace and kind of look at individual slides. So if you do see it jumping around, that's the reason it is intentional for today in the webinar. If you are just listening and don't have access to the chat for some reason, the slides can be accessed at a short link, which is posit or pos.it/rstudio-copilot, and that will get you to the permalink in the future. So as I mentioned, this is a talk that's kind of focused on GitHub Copilot, and it's really one that addresses issue number 10,148, which is, can we have GitHub Copilot integration with RStudio? There were a lot of people asking about this. There were over 500 people who gave a thumbs up indicating interest in this tool when it was initially prompted as an issue. And with this talk, we can officially close that issue, which is very exciting in terms of it's always really exciting to make progress with the development of RStudio as a product manager. But ultimately, it's really exciting to deliver these big features for people where there's lots and lots and lots of interest. So just making Copilot available in RStudio is one step, but I think we also need to understand what Copilot or other generative AI or large language model tooling can do for you what it can't do for you, and how best to use them to be successful. So that's really what I'm going to spend most of my time on today, as opposed to telling you how we developed it, more of how you can use it and ways to be successful. So I'm going to talk about generative AI, and for a lot of people, you've heard all about it. For other people, it might be kind of this amorphous idea that you might have heard a little bit about, so we can define it and talk a little bit more about that. So generative AI really refers to a category of models or tools designed to create new or novel content. So this could be text, images, videos, music, or specifically in our example, code. Generative AI tools use a variety of techniques. There's neural networks, deep learning, lots of different things going on that kind of meld together. But ultimately, they're used to identify patterns and then generate new or novel outcomes based on those pre-existing patterns. So some of the time this can mean actually retrieving examples from, like, if you train a model on a code base and you're trying to return exact examples. And other times, as you often are doing with something like Copilot or code generation tools like that, they might try to parse together different ideas or concepts in code to generate novel help for what you're trying to solve. A more discrete example of something I like using is there's a tool called Midjourney that allows you to take text or descriptions and generate images. So in this case, I have my favorite dog here, Howard. Howard is a Boston Terrier, and he's my little co-pilot as I'm working in my home office all the time. So I wanted a little indicator of, hey, I want my own little co-pilot buddy image that I can use. So to Midjourney, I can give a text prompt or kind of an ask of, hey, return something like this. Parts of it are going to seem very normal, and parts of it are going to seem kind of over-engineering or kind of artificial, but let's talk through it. So I'm saying, oh, I want like a graphic or a PNG with a transparent background. The image should be a seated, robotic style, Android-esque Boston Terrier wearing pilot or co-pilot goggles in the style of pixel art. And I want to see the full body. And then I'm giving some parameters of things like style equals raw and stylize equals 50 that just kind of manipulate some of the output I get. So while this is not really that many words in terms of maybe 24 words or so, I'm getting an image that is quite literally worth 1,000 words, right? Like, this is a pixel art that would take me a long time to generate on my own. And it is novel, although it's going to be similar to other pixel art that might exist out in the world. So this is a useful way of kind of like graphic generation or image generation was one of the first ways that a lot of people got exposed to generative AI tooling, but we don't necessarily want to stop there. Like, the goal is not to generate images, as much fun as that is. It's really to make you more productive at the task you're working on, which is probably more along the lines of doing statistical analysis or data science or development of software or packaging. So lots of other tasks that might be better suited to code or text generation. But that being said, I really do like my little Copilot buddy. I'm going to minimize this. I seem to have lost Zoom, so I'm going to grab those Q&A real quick, pull it over. Good. All right. So while we talked a little bit about generative AI for images, we're really focused now on generative AI for text. So rather than taking text to generate images, text to generate other text. In this case, the generative AI just wants to predict the next word, or what we often call a token, which is really like a string or some characters. So I might ask a tool such as ChatGPT. In this case, asking is also known as what we say is prompting, giving it a prompt to get a response back. Hey, complete the sentence every good ... And in this case, it'll say, okay, some little kind of forking path of what the next word should be. So first, the next predicted word might be something like thing. So every good thing or every good story, every good deed or action or plan. But we accept one word and we say, oh, every good thing. And so now it has additional context of not just every good, but every good thing must. Every good thing must, and then it predicts the next word. And you can see with these little numbers here that the accuracy or kind of the certainty that this is probably the next word is increasing. So initially there were some responses that were probably not a good fit. But as we get closer, we get to every good thing must come to an end, period. And that is probably a reasonable sentence for that might be the most common pattern that is seen in text of aggregating those different words together. So it is kind of a neat way to think about grabbing all the different components. The overall kind of forking path, though, generally when you're building UI or interfaces to this type of tool, you might see a situation where you need to reprompt, right? If I got every good story comes eventually and end, that's not really what I wanted. So I might have to ask again, like, well, try again and get another different fork or another different path to go down. But I just wanted to mention in terms of like, this is really all that's going on behind the scenes. Although I'm oversimplifying, this is really kind of the story. Let's go here. The other thing I want to mention before we get into some of the exciting part is while generative AI and large language model tooling are really exciting, we kind of want to trust it, but we really, really want to verify it in the sense of generative AI doesn't have a brain or general intelligence to speak truth. It's just a model that's been trained on a massive, massive amount of data. So it's kind of giving nice responses, but that training data might be biased in one direction or may not contain, for example, the code that you want to see, or maybe it was trained 3 years ago and a new R package comes out that it has no, training data on, so it can't really do predictions on that. The responses you get back are not always going to be right or the most appropriate or the most optimal. It's just a response back, and you need to work with that to hopefully enhance your productivity, but you do need to kind of work with it. It's not going to replace who you are as a data scientist or statistician or software developer, but it hopefully kind of enhances the speed with what you develop. Ultimately, it can make up things that just simply aren't true or use code that doesn't actually exist, or maybe it doesn't run. It's like 90% correct, but you have to adjust some small component. That being said, there are cases where it's really, really strong and you kind of take what it is and adapt it just a little bit. These making up things that aren't true, you might see them referred to as hallucinations, but realistically, it's just incorrect responses or a mix of 90% correct, 5% wrong, 5% kind of off base, but again, mostly useful. So overall, while I'm kind of hedging my bet here, it's really just important to verify the output before using it, trusting it, or generally just saying, oh, this is the right answer. It is an answer that can be useful, not always the perfect answer. So now that I've kind of caveated some of this, we'll go into what we're talking about today. Ultimately,
Tom?
we can, yes, go ahead.
I'm sorry, I was going to let you know that there's now 2 questions in the Q&A. So I thought maybe it might be a good time to ask them.
Sure, I'll take some of those at the end, but there were 2 questions around prompting graphics.
Yeah,
So
that's why I wanted to interrupt with that. Okay, sorry.
Yeah, absolutely. So I'll take those 2 at the end, but there's one about graphic generation and getting the suggested code instead of the actual code. And we'll talk about some of the different options there at the end. So if there are questions, please do put them in the chat throughout the talk today, and I'll address some of them live and then probably more of them afterwards at the, as we get close to the end. Thank you so much. All right, let's get back over here. So again, let's see. Okay. So again, kind of now that we've caveated and kind of took some of the wind out of our sails, we're going to add the wind back and some of the excitement, which is what is Copilot? We've talked about what is generative AI, what can it do, what can't it do, what is Copilot, what does it offer over a general generative AI tool? So if you ask the GitHub Copilot docs, they would say something like GitHub Copilot is an AI pair programmer that offers autocomplete-style suggestions or real-time hints for the code you're writing by providing suggestions as what is called ghost text. And this is based on the context of the surrounding code. The 2 parts I want to emphasize are autocomplete-style suggestions, and these suggestions are offered as ghost text, meaning it's kind of ephemeral. You are able to accept those suggestions or reject them, right? Like you've got this fork or branching of what is possible, and maybe what you got back is great and you can start working with it and accept it. Other times it may not be exactly what you're looking for and you need to add additional context or write some more of your own code, and then prompt again to get a different response. What this also means in practice is, what is autocomplete, right? Because all modern IDEs, RStudio included, already have autocomplete, right? So autocomplete in RStudio would do something like parse the code as well as the environment. So it understands like, oh, there's some characters you've written, there's some objects that have been loaded into memory, there's some packages that are loaded, and I can then make suggestions based upon that context. Importantly, autocomplete is supplying possible completions, right? They have to be possible based upon the existing context. And those are really a static set of completions that pop up for the user to interact with, right? It's not, it really is constrained to what is possible. And those are provided from your IDE, from your local disk, and they're kind of constrained to your local machine. Autocomplete is really useful, but what is this autocomplete plus with Copilot? What does that really mean? Copilot also can parse the code in the environment, but we're also adding a massive amount of training data. So you can imagine the generative AI tool or the large language models powering Copilot has been trained on millions and billions of examples of code in many different languages, including R, and it can supply likely completions, right? These don't have to necessarily be possible based upon the context, but rather what is likely and can go beyond what you have just in your local environment. It's a dynamic set of completions via ghost text as opposed to static, real kind of completions that pop up. And ultimately, it does need a connection via the internet to an API endpoint through Copilot to send a prompt, generate a response, and then pull that response back into your IDE. So a lot going on there, but ghost text, that's what we're going to hit on in terms of what that means for our environment. To put this into a graphical format, it might be useful to say, okay, well, here's autocomplete. I have a comment in line 1. This is only used for me because I'm the one reading it. But line 3 actually prompts the IDE autocompletion to complete this string. So if I type MEA, it probably means I want to type out mean. And so it says, oh, we can do mean or mean.date or all these different options or classes of the average or the arithmetic mean that you're taking. And it can give you a description of this based upon the static options that are generated. Importantly, again, this autocompletion is really just taking into context what you've typed immediately here, the preceding characters only on line 3. With Copilot, this comment actually becomes important. That is included as part of the prompt or the ask that we send across the wire to the Copilot API. And here, by just typing the letter M, I actually get a ghost text completion of mean. And because I've said take the mean of the MPG column in empty cars, it also fills in the empty cars $MPG, which will give me the average or the mean of that column from the empty cars dataset. So it's able to take additional context that a normal IDE autocompletion doesn't know what to do with. And this is ultimately part of the power, is you can document and add additional code over time to help your responses become richer and closer to what your intent is as you're developing or writing code. So this now means that RStudio has ghost text for the purpose of generative AI tools like Copilot. So in this example, in line 1, I've changed my comment a little bit. I say calculate the average fuel efficiency of cars grouped by cylinder, and I've loaded the dplyr library. So rather than just relying on base R, I've said, hey, I've got a library I can use. Try and use that to solve this problem. So now it still takes empty cars, but it uses the magrittr pipe, group by, summarize, and gives me an average MPG grouped by cylinder to give me this fuel efficiency. Notice I didn't say mean anywhere. I said average fuel efficiency, and it picked up miles per gallon and mean on its own from this context. Not that it's intelligence, but it's really, there's context here that guides the forking path in that direction. There's a great question from Kyle. I'll try and redirect some of those questions to Q&A, but would you recommend writing comments to get better help for Copilot responses before writing all the code? Yes, and that's what I'll talk about throughout the talk today, is some strategies to get optimal responses and where you can kind of tweak things to get a better experience when using some of this tooling. But comments are dramatically important, both for yourself to say, this is what I'm actually trying to accomplish, like they're useful just for that, but also they give context to the example that's being generated. So all of the kind of things you've written on your own, comments, code, even objects and memory are provided as context and sent across to the API. Once that is received, Copilot generates a response that is sent back to RStudio. RStudio populates this as ghost text, indicated by this kind of italicized gray text as opposed to traditional text. And importantly, this ghost text doesn't exist in the document until accepted, right? I don't have to take exactly what it gives me. I can choose to accept it, or I can literally like back out and tab again or control space to force a new prompt or force it to try again, right? Like I don't have to take the first example. I can type out more code or go down to another problem later, and that will add to the growing context moving forward. Another good mention that it's recursive or iterative. As you type more code, as you type more comments, as you get more responses, the responses often do get better on their own because there's a bigger context window. There's bigger semantic purpose behind what you're writing, as opposed to just one line of comment that may not describe the full problem you're solving. Now, I'd be remiss if I didn't show at least one live example. So on the next slide, I'm going to show a GIF of what this looks like in practice, and then I'll describe it and pause. But we're just going to watch this together very quickly. So I want to emphasize how fast that was, right? This auto-completion, this ghost text generation should feel like almost real time, especially for small problems or small generation tasks. It can be, 500 milliseconds or multiple seconds in the cases of generating longer responses, but especially for these fast problems or fast responses, they are really fast, like they feel like autocomplete. And what this means in reality, rather than watching the GIF over and over, I've provided a few pieces of my own code, some probabilities, a vector of random samples, and then a comment about what I'm trying to do. Return a function to calculate the mode of a vector. And this then generates a function called mode that takes the unique values and does a tabulate match kind of crossover to index and say, this is the most common value in your random sample. And I can actually use that in real time almost immediately. I can get a response, type out mode, put it on my vector of random samples, call that out, and then I get an immediate response back. So it's really neat how fast you can iterate with some of these smaller problems. And as you get into bigger problems, you can kind of break them up or segment them into simpler problems that are easier to solve for both you and auto-completion assistants like Copilot. There are a number of different questions coming up, and I think for most of them we'll be able to address in the talk, so I'm going to keep going. If you want to get started or try out Copilot, a couple things to remember. Copilot is a third-party tool, right? So you do need a subscription to Copilot. There are personal subscriptions, there's business or what would be considered like enterprise subscriptions through an organization. There are some that are available for free for academic use in terms of students, teachers, or folks working in open source with public repos on GitHub. But ultimately, after you get a subscription, you can go into RStudio, the Tools Global Options Copilot tab, and then you can download and install the Copilot agent that is not turned on by default, right? If you don't opt in to using Copilot, the agent is not even present on your machine, right? You have to get a subscription, you have to download the agent, opt into it, accept their terms and conditions, and then you can start using the tool. So you never have to worry about, all of my code is being sent over to Copilot API. No, there's actually like 3 or 4 steps before anything is ever going to leave your computer or be sent over there. Once you go through those steps, you'll then kind of navigate and log in through your existing GitHub credentials that have access to Copilot. You'll authorize the official Copilot plugin to kind of come back and interact with RStudio. and then you'll be ready to work. In this case, my GitHub profile is jthomasmock, and I've opted in to using Copilot, and I can now use it inside of RStudio, along with a few other kind of tools that I can use to tailor the experience. So ultimately, after you've gotten there, though, you're going to say like, okay, well, where can I use this? Where can't I use this? Like, can I use it in R Markdown or Quarto or only .r? Or what about SQL or Python or JavaScript or all these other languages? In reality, it really works in any of the code tools within RStudio. So obviously, you can use it in .r. You can also use it in R Markdown or Quarto documents as long as you're in source mode. You can use it in SQL files or even Python files or JavaScript or CSS, like all sorts of different files that you can use within RStudio as your project might grow. But ultimately, what I would suggest is you can say, I don't want to be afraid to kind of play around with the tool to see how it works, right? I don't necessarily want to go into a really high stakes environment where there's a time pressure and I don't have that time to play around, or I really need it to be rock solid from day one, but rather more of a toy example, or really figuring out where are the edges or rough edges or areas where you're successful. So for me, this playing around meant I want to play around with a literal game. Where Wordle was the game of the year a couple years back during the COVID peak of the pandemic, Keyword was an important game for my family over the past year in 2023. So this is a word game popularized by the Washington Post, although it did exist before then. And it's kind of similar to Wordle in the sense of you're trying to predict some letters, but it's almost like a mini crossword puzzle where you have a number of vertical words that each have one missing letter, and then you fill in each of those letters across and it spells one single word. So here I have blank, Limsey, star, something, all these different words, and I'm trying to, in as few guesses as possible, get to this case of what is a felony, which is flimsy, steak, kale, unto, seen, sway for my words going down. So how can we solve this keyword game with R, for example? Like I want to show my family, hey, I can always get 100% accuracy in like 4 seconds every time. And we can get there. And that's what we did here and why we can use Copilot to help solve this. So of course, that was the task I used with RStudio, with R, with Copilot to play around with it to solve a pretty open-ended and complex problem that can be broken down into a lot of simpler components. So to get the most out of the generative loop and actually be successful with these tools, and remember, GitHub Copilot itself is just a generative AI tool that is predicting or generating output text, and more specifically code, and it doesn't understand anything, so you can't just say, go solve keyword. It's just predicting these different components of your code. So you have things like context, what prompts have been provided in the sense of comments, other code, some cases like some tools can use URLs and browse the internet. What is the intent in terms of what is inside your own head that you want to do, and how can you encode that intent into context that then can be translated? And then ultimately, what is the output? Like, what are you actually getting back? And this context, intent, output is kind of that loop. That's the generative loop to me of you have an intent about what you're wanting to do that you semantically describe via context to generate an output that leads to more context that gets closer to your intent. So better context means you're getting closer to the intent of what you're actually trying to do, and ultimately leads to better output for this generative loop that you're using with something like Copilot. So I call this the S2C method, and that might be the takeaway for today. Simple, specific, and as someone mentioned in the comments, use comments, right? Try with these simple tasks that are highly specific, and you can use comments to help encode your intent into context for the tooling. So simple and specific, let's start there. Break down a complex task, how do I solve keyword, by describing a high level project goal at the top level comment and build off that with more specific tasks. For example, I know in my own head how to play keyword. I know other people have solved similar games such as Wordle with R, so it should be possible. And I might describe it with only comments to begin. So 9 lines of comments with a space. Create a function to solve the keyword game. This is how you play it. You know, there's 6 letters horizontally, and at the intersection of each of the words, there's vertical words that are a missing letter. And how do you play? You guess 6 letters across, and the letters must spell words across and down. That alone is helpful for me to understand what the problem is, but it's probably not sufficient for Copilot to just solve it right then and there, right? We have to break down this very complex task into smaller, simpler, specific tasks. So the simplest method is to cheat, or in this case, be clever. So using the JSON Lite library, I know that Washington Post actually publishes the raw JSON behind each day's keyword, and I can just get the answer out. Oh, it's staple for that day. So now I've solved it, and in 3 seconds, I know what the answer is. But that's cheating, right? Like I don't want to just cheat. I actually want to be clever about what I can do in there. So what else is in this JSON structure that's populating the keyword client? I can also find the words of the day. So this allows me to, without having to manually grab and pull the words over, I can get the blank letters and the rest of the word and then work with that in R. So the actual words of the day are really important context to provide to my R code to try and solve this moving forward. And if I wanted to add staple to that, we can see it does actually spell out real words, right? Like I can actually fill it in on my own computer and see kind of this process of taking the words, filling in one word at a time to fill letters, and then cross-referencing them to get the ultimate word that is possible. So this gives me the next step, which is just get the hint words, right? Break it down to the component parts. So, hey, Copilot, how do we get the hint words off of a URL? So now a few more lines of comments. Create a JSON URL function that takes a date argument because I want it to do every day because I'm trying to impress the rest of my family. Use the stringer R package to replace this dash with a slash, and then glue the URL together so that it will follow this kind of pattern and replace it with the clean date. And I go in and I type JSON URL, and then it generates this function that takes a date and then returns a URL so that I can actually call it once per day and get the keywords in the future. So, you know, I wrote a lot of comments and I actually got more comments than code in this example, but we'll build up and get a little bit better over time as we add more of these comments for further functions. So in this case, I've simplified it to just get the hint words. So take the JSON URL from this date, parse it with JSON, throw it into a character and give me the hints back. This was code I wrote, right? I'm adding on to the context of what Copilot has helped me out with. But now I've made progress from taking a task where it's fully manual to one that I just have to supply the date and it can give me back the words I need. So that gets us to step 2. We've simplified the problem, but now we can use, beyond just comments, we can use expressive names. So expressive name for variables, for functions, for objects. And realistically, this is something you should be doing anyway, is having expressive names that actually describe the purpose of what you're trying to do. So 2 comments, given a word like underscore ac, return a regex that will match the known letters, but any lowercase letter instead of the underscore. So then I start typing regex, and before I even finish the name, it says regex from word. Yeah, that's what I'm trying to do, is I supply a word, it returns back a regex that I can then apply to get all these different examples. Uses string R since I've already loaded that earlier without me even having to say anything, right? So the context is growing, it's getting a little bit better. Now, the next example is without any other comments, just from these previous things, I can say, well, now I want to take that regex from word with my intent, and I want to get the matched words. Again, no comment here, right? But it fills in string subset. I've got another function I've defined called limit words to 4, regex from word ac. I've skipped a few other functions I've written, but I didn't have to write a comment here. It's just putting together all the component parts I've already defined. So that's the case of where the expressive name of matched words has a semantic reasoning behind it, as opposed to something like MWRD, which might also mean match words, but it's not very descriptive or useful in a predictive context. So we've made progress. We're getting some of the match words that are possible. And now I can put just a 2-line comment of put the matched words into a function that splits the characters. Then it will score the letters with a function I've defined called score letters to return the top 50 most likely words based upon what fits in each of those different component parts. So I start typing out top underscore words, and it gives me this quite long function with a couple lapply and sapply, a couple different things going on, and it actually returns then the top words for me to use. And I can start typing things like letters from blank and get the individual letters that will make up the horizontal portion. I'm going a little bit faster here now because we're less interested in really solving the keyword game for y'all, and more of like, as we've added this more context, our responses are getting better. And you can see that Copilot is even adding little comments alongside based on other things I've included. So this is position of underscore in the string. So all this together, again, we've simplified it to specific problems. We've added comments throughout, and we ultimately get to this guess keyword function. So when I initially put all this together and I was solving keyword in September of last year, we can now say, hey, guess the keyword for this date. And it says the keyword is one of the following words, recipe or repipe. And to, I think, a couple people's comments in the chat, why is it using the McGritter pipe instead of the base R pipe? Because it was trained on data from a few years ago. So while it can actually autocomplete the new pipe, the R4.1 and beyond pipe, it's probably got a lot more training data on the older McGritter pipe. But I don't even know if repipe's a word. So I'm gonna guess that the word is recipe. I love recipes package from part of Tidy Models, and that is actually the word of the day. And that gives me RAID, state, cap, gambit, parent, decree, and that solves keyword for me. If you're interested in kind of solving keyword yourself, I have a full transcript of this iterative process of writing my own code, writing comments, getting responses back at a gist on GitHub. And then I have the full guess keyword function that was kind of aggregated and mashed together into this 1-line function that takes a date and gives you back these predictions. So as much as that was fun and it allowed me to kind of be like, hey, I can now always solve keyword in less than 5 seconds, it hopefully showed us that the power of some of the comments, the power of expanding our context, simplifying things, being more specific, doing all these things together. So eventually, and as I did in some of the prompting that I did, you're going to get stuck or get to a state of where some of the responses are probably not exactly what you want. So what you can do is, again, add more context. And again, follow that simple, specific, and use comments, S2C, to improve the quality and get closer to the intent of the response you want to get back. You can also prompt again or in a different way. So rather than doing only top-level comments, you can put comments inside the body of a function or even in the body of a McGritter pipeline or a base R pipeline to suggest new functions or new calls within your existing transformation. You can add more comments wherever you'd like. And ultimately, you want to build off your own momentum, right? Write some of your own code. You don't have to, you're not going to get replaced by Copilot. It's not that good. It's just trying to make you a little bit better and be more productive when writing your code inside of RStudio and elsewhere. And ultimately, sometimes you want to turn off Copilot for a bit if you just want to sit there and think, as opposed to this quick burst of energy and this quick kind of iterative process. Sometimes you just want to think and read and go do some other things and then come back to the problem. So you don't always have to have Copilot on, and sometimes it can be a bit noisy if you're doing a bit of a slower development process. There are still a bunch of questions in the chat, so I'm going to look over some of them. It is quite common to have more comments than code, especially as you start. And I think that's part of what I'm trying to emphasize here is the use of comments is useful for you as well as for generative AI tools. If there are people that want to use things like the base R pipe, Copilot is actually pretty good about picking up on what you've used before. So for example, in scripts, older scripts I have that have the McGritter pipe, it will often always suggest the McGritter pipe. But then in newer scripts, when I'm working in R4.1 or 4.2, I have the base R pipe and it picks up on some of that context and uses that for pipelines. But you might run into situations where it's doing a mix or both. There are some questions about privacy and how the data is being used. I think it's really important, again, to emphasize this is an opt-in tool. It's a third-party tool. You have to go through a number of different steps before you can even activate it, right? So from day one, you don't have to worry about data being sent without your you being involved. But it's often good to think about what does it mean to send data or code across the internet to an API. I can't really answer that question for you. For some folks, they're like, oh yeah, that's fine. Everything I work with is great. Other people might work with patient information or PIA data or other HIPAA data or whatever, where there's much more conversation that needs to go. And you might need to purchase like the business class where they have different grades of what data is being used or use it in a different way. So if you do have concerns about how the data is being used, I think it's important to read through the GitHub Copilot documentation itself, because that's ultimately where the data is going and how it's being used. As far as where the training data came from, so that came from, as far as I understand, the public internet. So obviously like GitHub itself has millions and billions of examples of public code that can be used to parse into a training data set. There are options for opting out of public code or use of things like that if you're not comfortable with it or if you have concerns with it. And it really has been trained on a whole host of different languages, right? It wasn't written just for JavaScript or just for C++ or R or Python or SQL. It's a mix of all those different languages. So it's not limited to just one tool, but it can also write in multiple different ways. Ultimately, you can turn off Copilot for long-term or for short-term. Like if you activate it and don't want to use it, there's a quick shortcut in RStudio to turn it off. And you can turn it off completely and opt into it in other projects if you want to do that. I mentioned it earlier, but Ghost Text does work for R Markdown and Cordo, and it can actually type out text or in code snippets actually do some code completion. Although sometimes it's a bit finicky about if you don't have a code chunk and you try to write code, it can duplicate some of the backticks to set up a code chunk. So I'm going to move forward and then we'll answer more of the questions as we go forward, but I'm going to answer a few of these live. It will work with languages like C++, I believe. I have not personally tried that, but it should work for any language you can type. And you can turn it on and off for specific settings you want to use. For Posit Cloud, I think there is some work in progress of trying to make that available for folks. And you can opt into using it with your students, but importantly, that is kind of a double opt-in process of there has to be a subscription to Copilot and you have to opt into your students then using it. I'm not able to there's a question about licensing of code generation. As far as I understand, it is you writing the code or being enhanced to develop the package. But as always, I'm not a lawyer and I can't really tell you about how to license code as you see. So we're going to move forward from here. So ultimately, as you do all these different things and hopefully get unstuck, you'll get better context that gives you closer to the intent of what you're trying to do, leading to better output about what you're actually trying to solve. Now, as exciting as Copilot is, and having this little backseat driver is often really helpful, it can also be maybe not exactly what you want. And maybe you want to generate text in a different way. Ghost Text, really, really cool. It's literally in there with you as you're typing. It can help you autocomplete things in a much richer and faster way than just having to type it out yourself. But again, sometimes that's not exactly what you're trying to do. So what if you wanted to talk to something like ChatGPT or a chat style interface that allows you to ask questions and get both text and comments and code back? That's the purpose of the chattr R package. This allows you to, from within RStudio, within the viewer pane, actually type out questions and submit them to a number of different backends, including ChatGPT, or even local models that never actually have to leave your computer, such as Llama, which is a C++ model that can run on pretty powerful but desktop or laptop environments. And this allows you to truly get a chat style interface along with the ghost text that you're getting from Copilot. So again, Chatter is an R package, so you can download it. It has an add-in that allows you to display things in the viewer and interact with it. It can also do some inline generation, but as of today, it doesn't really use ghost text. It's just filling in lines. So the primary use case is to use it within the viewer pane where you're asking questions and getting responses back. Chatter does something really cool, which is what we call enriched requests. So even though I've only really loaded 3 things, so the Chatter R package, I've attached some data, mtcars, and iris. If I were to interact with Chatter, it's actually enriching that data with more than just what I have, right? So in this case, I'm working with ChatGPT 3.5. And the default, although this is customizable by you as the user, is to add in some enrichment to your prompt. So it says, hey, there's a couple books like Tidy Modeling with R, R for Data Scientists, some Tidyverse packages for modeling, for explanations and kind of how to return responses. Give me the response back in this way. So that helps the responses be more code friendly, but maybe you want to write a different language, or maybe you want to add in additional context or mix and match things. So you can actually customize that prompt further on your own machine, kind of through like a profile method. And it doesn't have to be ChatGPT. There's a number of different models that are supported as part of the backend for this. What this means from a diagram perspective is you ask a question, but in addition to the actual question you've asked, it also says, hey, there's data files, not reading the files, but just the file names. There's the name of data frames in the environment. There's all the enriched prompts that we add by default, but you can customize. And then with ChatGPT, it also includes the history of the conversation or the questions you've asked before, so that context can grow up. That is then sent over to the model endpoint, and then you get a response back that streams to the IDE, fills into the pane inside the viewer pane, and fills it out with a response. So, a lot of different ways to do this, but there are generative AI tools. This obviously works with RStudio Desktop. We're in the works with using it with Posit Cloud. And of course, it can work with Posit Workbench, our professional product for on-premise use. And for the best outputs, you really want to follow this idea of simple, specific, and use comments, or S to C, right? Break down the component into simpler parts that have a specific purpose and use comments to help, encode your intent. Importantly, GitHub Copilot is an optional integration. It was available as a preview feature in the September release last year, and as of the December release of 2023, it's now generally available for RStudio, for Posit Workbench, and RStudio server. If you have feedback or run into bugs, you can always open up a GitHub issue on the RStudio repo. We're doing some improvements there. And importantly, the Chatter package is kind of a separate tool, but in the same large language model generative AI space, right? So it can work with OpenAI models or work with locally hosted models like Llama, and there'll be more backends that are probably added over time, and you can install it from Crayon now or from GitHub at mlverse/chatter. Now, the closing kind of remarks as we get closer to the end is whether you're a cat person or a dog person like I am with my buddy, or if you like arbitrary fictional characters like Totoro, you can get all these nice little cool photos from things like Midjourney, and you can also generate code and have them be your little Copilot buddy in your own head. So I've got some additional slides, but I'll save that for later. There's a number of questions that I will close out. Let's do done, 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 done. Can Chatter be used without Copilot? Yes, that was an important part, is that Copilot and Chatter are separate tools. So Chatter actually can use OpenAI directly without a subscription to Copilot. So there are some free tiers for OpenAI ChatGPT. Although again, you'll want to be careful with kind of your comfortability with sending responses or data across there. And it can even be used again with local models like Llama, where your code actually never leaves your workstation. And I think that's really attractive for some organizations where they actually want to develop against locally hosted models that their team or their organization has developed. I'm going to parse through some of the questions, but I'd love to hear more from y'all. If y'all have questions, please do type them into the Q&A. Looking through some of these. Can it pull context from the file you're working in or the whole R project? So I'm going to go into RStudio. You can see I have my Copilot slides here written in Cordo. A couple things to mention. So for the Copilot, you can, first off, you optionally opt in to enable or disable Copilot. There is an option to what's called index project files, meaning it doesn't just work on the files you have open or highlighted, but it can actually read context from .r, .py, .sql files that are in your project. And this is called indexing of those project files. This is optional. You don't have to have it read from there. And sometimes that's very useful, and other times you don't want it to do that. If you wanted to turn off Copilot quickly, using Command-Shift-P to open the command palette or Control-Shift-P on Windows, you can search for Copilot, and there's options to both like interact with Copilot as well as turn Copilot on and off. So I can immediately turn Copilot on or off and then keep working with the tool in that way. So that was that question. The other thing I want to mention is that while ghost text is kind of associated with GitHub Copilot, I also want to call out here, and maybe this is a little small, so let me zoom in. There's an internal API called set ghost text, that this is what is actually powering the ghost text that Copilot generates. And importantly, this can interact with anything, right? It doesn't have to be Copilot. That's just the integration we've kind of built in. You could actually have this and develop your own R packages or add-ins to work with other backends or even a locally developed model. So here, if I execute this code, it says, well, let me do this real quick. There we go. You can see that it actually generates ghost text saying arbitrary LLM backends can be built to use RStudio's ghost text. Y'all could set up an add-in for RStudio. And just as you'd expect, I can tab to accept that ghost text, right? This never left my computer. It was just me interacting with that API manually, but you could have it be an R package you've developed that's talking to an arbitrary URL or API, or even a locally hosted or organizational hosted model, which might be the only option for some of these extreme security environments. Again, like I don't want to get too far into this idea around what are the constraints or privacy aspects. Like I'm not the best suited person to answer those questions because it's really up to the contract you have with GitHub and GitHub Copilot, but they do have rich information that I've linked to in my slides. There's some additional context. Apologies. I think it's in slide earlier. Let me pop these out. What is Copilot in RStudio? So there's a GitHub Copilot terms of service that goes through exactly how they use data, how they store it, what the different license tiers mean. And I think this is the resource that you want to start with in terms of understanding how Copilot operates. As far as additional tips for efficient prompts, I think, again, the more purposeful you are about writing code and what problem you're actually trying to solve, the better a tool like Copilot will be. For example, like I can go in here and with no comments, just start typing like mean. Well, I think I've turned off Copilot. So let's zoom out a little bit. Whoop. This is always risky when I'm doing Copilot and setting things up because it's non-deterministic, right? It's a random tool. So I never quite know exactly what I'm going to get. But let's say generate a dplyr pipeline to summarize the mtcars data set. We'll keep it basic. And it's first giving me back a comment saying load the mtcars data set. maybe that's not as needed. And then we can go to the next line, go to the next line, dplyr. So let's say empty cars and try again. And now it's generated a pipeline. Importantly, you can see because I used base R as the pipe, it did populate that forward. And I need to load the dplyr package. So let's run that. So that did give me a functional pipeline pretty quickly, although I'm just kind of randomly giving it a problem, right? Like I don't even really know the problem I'm trying to solve, but it is able to generate those completions, right? So trying to understand like what you're trying to do, encode some of that with comments, break it down into those simpler component parts is really useful. But you can always add like additional comments in line of like, oh, I want to rename the columns, and you can rename them. Although here it's just renaming them exactly as they are read. Maybe you want to do average MPG instead of mean miles per gallon or something, but you could work with that. Yeah, there's a good point from Stas here about longer snippets of code. Importantly, there are what are called context windows or response windows. So you can imagine that 4 or 5 lines of code that are pretty straightforward, probably pretty good at that. Empty cars, probably seen that a ton in the training data. But random genomic data set that only I've ever seen in my entire life, maybe it needs a little bit more help with doing autocompletion. So I think even with these longer problems, and especially if you look through the interaction I had generating the guess keyword function, that's like 100 something lines of code, right? Like it's a non-trivial problem. Let's go back. Oh, I restarted the, we're gonna render this. I have to get back to my slides. If I were to go to that code, and let's pop it out into its own browser. Bouncing around a bit, apologies. So playing around, guess keyword. Okay. So if I were to go to the transcript of like how I got there, right? Like this is 200 something lines of code that I wrote with assistance from Copilot, right? But it wasn't all at once. It was, 5, maybe 6 lines of code at a time. And then I can roll that up into an actual function that itself is about 166 lines of code, right? So you're not trying to write it all in one go of like, most of these tools wouldn't be able to generate 166 lines of code in one shot. It would be building up the component parts that then assemble into other ones. So it's really kind of, you want to be careful not to try and make it too big of a problem. There's also a great point is a question and kind of a comment is, rather than using comments to generate code, is Copilot useful for helping decipher sparsely documented code? So you could have it, you can do things like, not necessarily the primary use case, but explain this code and have it do something like empty cars. I'm going to use that example, group by cylinder, summarize mean equals mean of MPG. And then I say like, explain this code and see if it'll get me there. It's just going to kind of over and over type explain this code. So what does this mean? It's not really intended to be used as a chat interface, right? Like it's meant to generate code, as opposed to chattr. And if I go to the chattr app, pop up in my viewer here in a sec, I can say, explain this code and submit it. And this will actually say, oh, well, here's what you're doing. And it actually goes through and defines what I'm actually doing and streams that back. So a true chat style interface is probably better at defining and answering questions, as opposed to Copilot is really intended and optimized to generate code as an auto-completion help. How effective is Copilot in accessing the function package documentation, RStudio comments will be found next to the function definitions, but vignettes may be removed, although functions may be encountered in those. So one, I have used Copilot moderately successfully to actually help write R packages in terms of, because they're very structured, you can actually have it work with some of the RStudio comments. There's lots of, again, content about that in the training data. But especially because it's a little bit finicky, you might have to give it more help for writing those. Anything you define in line, like novel functions you're writing in a package yourself, that's where it actually is really good. Like Copilot's really good at software development and pretty good at like computational pipelines. The reason being, like a computational pipeline or a deployer pipeline is very open-ended. And it's really like, what are you trying to do versus software development? You're really writing out kind of exactly what you're trying to accomplish and trying to get the bits and bytes to line up with that. There's a great comment about what about SAS code? So that actually came up in a previous question. Convert the following SAS code to R code using the deployer package. This is, sometimes it works, and I won't say it's perfect, but we'll see what it does. So library deployer, we'll wait for this world temps. So it says, I hope you have the world temp CSV locally. And then it gives you a mutate filter arrange select. So y'all can tell me, and I'll put this into the chat. Does that actually align with what you'd expect for the SAS to R code? And I would generally say there's a lot of open source code, but especially for things like SAS or other languages that are programming languages, but not open source, you're going to have some issues with it being present in the training data. But because some of these are words in the sense of like, we can assume the intent, we can probably do translations. And similarly, I can drop this into a chat style interface and do a similar thing. And it gives me something pretty similar. So let's see what it does. It sets the working directory, which is interesting. It reads a SAS file, so that's good, but you need to load the package. And then it throws an error because I think the response may have been too big or something there. So it happens, but let's reload. So depending upon what you want to do, it might be helpful, but this dream of just feeding in thousands of lines of SAS code and getting 1,000 lines of dplyr or R code or data table code out, probably not realistic, but incrementally converting, probably pretty good. Another good comment around proc SQL, probably an easy case because SQL is very close already to dplyr, probably true. I don't know anything about SAS, and I appreciate not having to live in that world personally, but I know that there's lots of other folks who really like SAS, or maybe they want to mix and mingle. So up to you in terms of how productive it can help you out with. Any context window restriction when a program can be long, can we scope the input of the context to Copilot? So part of what you can see is with the settings with like global options, Copilot, what you can do to control the context window is A, turn off index project files, so it's only pulling from actively open files. And then you can actually close down everything but like the file you want to work on, or incrementally add other files that have been opened in RStudio into the source pane. So those are what's going to be used for the context. Cool. So we're at the top of the hour. I think we've got about 25 minutes left remaining at the max. I'm happy to answer some more questions. I'm trying to look. I don't see any questions in the Q&A currently. And it looks like there's some lively, good discussion in the chat, but I think if we do have questions, let's put them in the Q&A. But I'm happy to stick around for another few minutes and answer questions. We still got almost 200 folks still here, although now that I've said I'm getting closer to wrapping up, we are losing some folks.
Hey, Tom,
But-
I'm going to, I'm sorry I'm interrupting, but
Yeah, go ahead.
I can't put, it seems like I can't put anything in the Q&A, but, and I'm sure I could look this up. But anyway, does Copilot also work with, like the Copilot itself, does it work with like Python, and maybe other computing languages, computing language?
Yeah, that's a great question. So if I were to go into Python and we'll just try and prompt it real quick of like use pandas to read in a CSV, just something real basic. It'll work inside RStudio to import all these different things. And again, not huge Python programmer myself, but like you can see that it is generating Python code. It is importing, like this is valid in terms of we're importing pandas as PD, and then we could append PD plus the function or object forward to do that. So it'll work with R, Python, SQL. The only thing that I would think is at risk is, again, code that isn't open source, such as, again, like SAS. Probably not the best thing it's going to be at generating, and your ability to execute that type of code in something like RStudio, probably not ideal. But C++, Python, SQL, I think seen some people even do Stan. It's been good at. There are, like, if I wanted to do testing Cordo. So if I were to go into a Cordo document and ask for it to do something, it can generate code inside code chunks, as well as like it can generate pure text of what it is doing. And it's just like, oh, this is what's going on. It can work with the different parts of like, oh, generate text versus generate code. It can generate Python code sometimes in line with R code because of the code chunk delineation. Although you have to be pretty careful if you're mixing back and forth a lot, that you do have those indicators. Like it's trying to say, oh, well, you probably want an R chunk next, and we need to complete it before we're really starting to prompt it again. But it'll work in all these different contexts for sure.
Oh, that's pretty cool. So I guess I'm guessing that with the large language model, I guess that's behind Copilot, that it's maybe been trained using sort of a constrained data set, or in other words, if you're generating data or software or code or whatever, you don't really need to input like novels or news stories or that type of thing. I'm guessing that the large language model is just using data, training data that's based on code.
Right. That's a good point in terms of like, it's only able to generate what is in its training data set, which especially for Copilot, I think it's based upon the Codex OpenAI model, which is like billions of example of code, but it's not going to contain pop culture as much news, although some of that does bleed in. Like you can have it complete nursery rhymes and things that seem kind of ironic or famous quotes. But it is really tailor trained or tailor made to be really good at a specific task, which is code generation. And it's probably okay at doing some other things around, like it can generate some text and it can help you write a little bit of prose to go in your Cordo document or describe it with comments. But I would not think of it as a super Copilot for writing a book, for example. Although writing a technical book about R, Python, JavaScript, something like that, maybe it would be really helpful initially. I think it's a good point. I'm reading off Stas is like some of the public code that has been trained for, say, SAS or Stata may not be the highest quality. So even if it can generate or translate some of that code, it doesn't have nearly as much training data as it would for an open source language. There's a question from Winston about, is Copilot available for Databricks? That kind of depends upon what you mean by that question, but RStudio has a plug, like has a ability to call Copilot from it. So we're working with Databricks on bringing both Workbench with RStudio Pro into their future environment called Lakehouse Apps, which is a way of hosting Posit Workbench inside of Databricks as a first party. Or from a local Workbench or RStudio environment, you can interact with Databricks remotely, and Copilot can generate Sparkly R code or SQL code for Spark SQL and things like that. Can you please describe again what data is being used for just suggesting the code? It is kind of up to you in terms of what that means. That really means like the control parameters you have are within RStudio by default. You can turn off index project files, which means it's only reading from files you have open, right? There are the names of the files in the environment, as well as auto-completions can be sent across, but it's not reading CSVs or reading data, for example. And if you have that turned off for index project files, it won't read from things you don't have open. Question about training data. We currently don't have plans to create a corpus of R code. Almost all the textbooks that we write, as well as the lots of the code and packages we develop are open source or openly available. So they're probably present in a lot of the training data for various models. We have talked to different folks about, is there something we can do to help contribute in that way? But right now, like we're open sourcing and providing free textbooks as much as possible, and those can probably be used as is for training purposes. How adept is Copilot at modeling tasks versus writing functions? In my personal experience, I've had more success at writing functions, although because again, software development can often be more discrete, simple tasks, as opposed to modeling tasks. You're adding probably a lot of your domain expertise in there. And I don't want to say software development doesn't require domain expertise, but they are different types of tasks. And so for modeling, maybe it's good at writing boilerplate for something like tidy models, which you like build up a workflow and you have like parsnip recipes and all the different components. And it's really good at doing something like that. Or with chattr, the ability of like, parsing that book to use different help or to understand that code. But you're probably going to have to enrich it with your own domain knowledge or fill in parts and have it add on to it, as opposed to just develop a boilerplate set of default like linear model or something. Cool. Okay. I think that's all the questions in the Q&A. I'll give it another minute or two unless Wendy or Donna need to leave. And other than that, it was a pleasure to be here. Thank you so much for having me. Again, I will drop a link to the slides. Let's see if I can get these in. Yes. Okay.
And Tom, thank you so much. I just wanted to make sure there was a follow-up question from Jackie in the chat.
Yes.
And you may have answered it when I was not paying enough attention, but I wanted to make sure you saw it. It was right under the bunch of about 6 after 4.
Yeah, yep, I see that now. Thank you.
Sure.
Another follow-up question, can we use selection block as direct input of the context to Copilot? Sometimes we can give better context with this. So there is kind of this idea of weighting what you're prompting with. So whatever is closest to your cursor, that's where it's going to really pull from. Like, even though there's all this context that is available in the training data, in your environment and everything else, whatever is closest to your cursor, or whatever is like the last thing that was asked or commented, that often is the most important part for filling in the completion. So there is the also, I don't know if that's a word, Copilot. You can also have it do things like request completions or accept new words, toggle automatic completions, where you can change some of the shortcuts and assign shortcuts to that. It's kind of the ergonomics of how you want to use it, as most people accept entire chunks, but you could have it do word by word or force it. Like if you highlight something and then force it to generate a response. Let's see, Copilot, request completions. And it says like there's nothing available, like interacting with that. But if you do have feature requests, please do put them into GitHub. Question from David, do you need a token to install chattr? You don't need a token to install chattr, although I think it's on, let me turn in my job. I believe it's on CRAN now. Chattr. Okay, chattr is still only on GitHub. So it would be remotes install GitHub MLverse chattr. And, you know, if you are using this, it's going to be pulling from a GitHub personal access token because it is pulling directly from GitHub as opposed to Crayon because it's not there yet. So you will have to have that portion set up. And if you do use something like OpenAI or ChatGPT, you do need a login for that because it's a public API, but you have to, you know, even for the free tier, you have to have a login or a sign up. And then there are also paid tiers with different use of data. Okay, great. We're losing some folks, so I'm gonna turn it back over to Wendy and Donna for maybe any housekeeping. But again, thank you so much for having me. A pleasure to always to talk to the community here, and good to see some happy faces and great questions.
Yeah, thank you so much, Tom. This was fantastic way to end the day. And as Donna can attest to, that this is our favorite meeting or gathering, I don't know.
Yeah, and Wendy, I just want to say that I don't think I have ever seen so many applause, icons, characters in a chat for a webinar. So Tom, mega kudos to you for delivering such a great presentation.
Yes,
We stand on the shoulder of giants who helped develop a lot of this, so thank you all.
Well, you and your co-pilot did a fantastic job.
He's asleep on the floor. He says thank you, though.
Well, thank you again, and I'm going to give you some live applause. There you go.
Thanks
All right.
again.
Well, thanks everybody. And for those who are still here, remember the chat, the information for YouTube's there, and our next event in February, and we will advertise it widely. And thank you again. This was just fabulous. So
And
thanks again.
maybe, Wendy, I'll just give people a heads up that the event is on February 22nd. So 1 week later than we normally do our Govys stuff, but
yeah. But it actually works a little bit better
worth
that
waiting
way.
for.
Yeah. I'm gonna go sign up now.
Cool.
All right. Take
Thanks.
care. Thanks everybody. Thanks, Tom, and thank you, Donna.
Yep. Bye,
Bye,
everyone.
folks.
All right. Bye.
Thanks.